Welcome back to the XD500 restoration channel. What we're looking at here, some handlebar mounts. There's a decomp and clutch lever and the heat guard off the engine header. They're all painted up, ready to go. Next on the list, there's a few rusted bits and pieces there. They're going to be painted up with gloss black. That was their original colour. So there's some rust removal, some sandblasting to happen there. Have a look at all the nuts, bolts, washers and other sundry items that have all at some stage been nickel plated. What am I going to do with all those bits and pieces? I think there's only one possible solution. Order and take delivery of an electroplating kit. So, electroplating's all new to me. So let's get this kit unpacked and see what's inside. Let's have a look what we've got in the boxes. Our electroplating kit. Some chemicals. And whatever that is. Let's see what's in here. As he slices straight through the whole thing. Some aluminium tubing, I think for putting across the top of the tanks. Now, there is some product labels on these from the people that I bought the kits off. I'd like to say that I am in no way affiliated with these people. I'm not taking any kickbacks or anything like that. I'll give you an honest review of how the kit works. If it's good, it's good. If it's rubbish, you'll find out it's rubbish. Well, ease of use. Final parts cleaner before plating, that one is. Rust and scale remover. We've got so this kit I've just come across by searching online for electroplating kits. This is an Australian one. I think they were based in New South Wales. Zinc brightener. So many chemicals, eh? Zinc additive. Don't know. Hope that's all still in the shop there. Yep. And this one here. Oh, these are a couple of colour. They add colour to the final plate. So this one here gives you that gold, iridescent gold colour, and this one a blue dip. Don't know, we'll have a bit of a play with those. Well, that was box number one. Let's go for this one. So we've got some copper wire, alligator clip. So that'll be for suspending all the bits of plating in the solutions. Look, zinc anodes. I think that's the right terminology. They're the ones that give off the electrons that stick to your product. This kit said there's enough in here for 5 square meters of plating. That's a lot of plating, but I've got a lot of projects coming up. This one here, pre-dip passivator. Oh yeah, this is a little circulation pump. This runs in the bottom of the electroplating bath to keep the solution moving. Basically a little fountain pump, that's all that is. Nothing too spectacular there. Some gloves, yeah, got plenty of gloves. Wires. Not sure what, probably just more wire for suspending things in the solution. A couple more chemicals here. Clear thermoplastic acrylic lacquer. Maybe for dipping parts in once they're treated, I don't know. Like I say, I've never done this before. It's certainly like Christmas, eh? Clear thermoplastic acrylic lacquer. Oh, they're the same. 50 mils. Alright. And here we have supposedly, like I say, I'm not affiliated with these people in any way. Oh look, there's a few nice colour pictures there, how to set it all up. I like pictures. All these word things, what do they mean? Nothing. It's all in the pictures. Okay, maybe a little bit in the words. Right, next box. One to go. It's Christmas in the workshop. I don't know where I'm going to set this up. It's going to have to be in a very clean area. Warning! Chemical bags will tear easily. Please handle plastic bags with care. No worries. Oh, okay. It's just the one in there. In other words, don't go slicing willy-nilly with the knife. We don't want to puncture any bags, if we can help it. Okay, that's just one bag. 20 litre zinc mix. There you go. I'm guessing that's the electrolyte. That'll make an electrolytic solution for transferring the electrons around. Zinc electrons. Alright, that's everything that's in the kit. So obviously I've still got to get a couple of buckets. A couple of buckets for myself. And, oh look at that. There's a motorcycle brake lever there. Alrighty, well, we'll get it set up and see what we can do. Alright, we've got the meth lab set up. Electroplating system set up. I've got to mix the chemicals yet. But as you can see, we're all ready to go. Got some containers, got all the bits and pieces, got the little circulation pump mounted in there. These are going to be the these will be the bars that conduct the electricity and hold the anodes in there. But I need a power supply to drive it all. So I'm going to work on that. Right, the power supply I'm going to use is an old drill charger. It's an old Bosch charger. It's just a switch mode power supply. I'm going to change a couple of components on the board there to give me some current regulation. Alright, so this will be the plan. We'll modify this charger. That'll sit in that little enclosure there. It fits. Lid on there. Just got an old analog focus. It's got an old analog current meter there, amp meter. That'll go up there somewhere. A couple of terminals to get the power out of it. There and there, somewhere. Maybe a LED just to let us know it's on, it's powered up, but then again we'll see the thing there. And then, what else do we need? We're going to need some kind of adjustment, so we'll just whack a variable resistor on there. I don't know, whichever one's the right. What's that one? No idea. That's handy. Oh, never mind. This one here is 5k. That'll probably do it. That can go on there. Right, let's get all that working. Okay, what we've got here, switch mode power supply. Quick disclaimer warning, 240 volts on this side. All of this from this side over here, all 240 volts, and some of it is over 400 volts DC. So be careful when you're mucking around with this stuff. Now why it's called a switch mode power supply is because it's taking the 240 volts through this little transformer here and out the other side, and it's producing 12 volts to charge the battery. Back in the old days, to get a 5 amp battery charger, which is what this is, 5 amps, you needed a transformer of that size. You can see the size difference. 5 amp continuous output, 5 amp continuous output from 240 volts. Big difference. That weighs about 2 kilos, and I don't know, a couple $100 worth of transformer there. This weighs about 100 grams, maybe 150 grams. Wee little transformer. And the reason why they can use such a small transformer is because they're increasing the frequency of the switching on the transformer. So it's coming in here at 240 volts at 50 hertz. It gets rectified through here, through the rectifier, into this smoothing capacitor, into DC. Then it gets switched to very high frequencies by this transistor here. And the frequency is usually above audio level, human audio level, so audio hearing frequency. So it's usually around 40 kilohertz, something like that. And that 40 kilohertz, because you're switching it so quickly, you can have a very tiny little transformer with very few windings in here. And that's the trick to it. High switching, low number of windings, not very much magnetic flux through the transformer. Then of course it comes out of the transformer, goes through a choke here that just smooths it out. There's a big rectifier here, and then most of this these small components here are just voltage regulation and battery monitoring. So it's monitoring the condition of the battery. And this was only a NiCad battery, so it wasn't overly sensitive like the new LiPos. So let's get this, let's have a look at this thing. So to control the voltage, this is sensing the voltage of the battery, and it's got to send a signal back to the 240 volt side. Remember, 12 volt side, 240 volt side. it's got to send a signal back to here to control the voltage, and it does that through this little optocoupler. And what an optocoupler is, it just means that there's no physical connection between the high voltage and the low voltage side. It's done by light. So there's a little variable resistor in there and a diode, and that's how it gets the signal back across. If you have a look at the back of the circuit board, you can see through here there's a big separation between the high voltage and the low voltage side, and I've already started fiddling around with it. That's why there's a resistor here to not bypass this optocoupler, but to change the voltages into that. So what we need to do is put a variable resistor from a power supply on this side of the 12 volt power supply on this side of the board into the optocoupler, and we're bypassing the voltage control. Now you've got to be careful you don't go too high, because you'll blow the power transistor on the 240 volt side. So let's get into it. Oh, we're going to plug it in. We'll see if it goes pop. We'll just check there's nothing under there that's going to short it out. In fact, we might even just sit it in there, just for a little bit of added safety, just in case it does pop. Still in shot there? Yeah. Oh, that's a good sign. The green light's on. Got to win the odd one, eh? Oh, that's interesting. 73 volts. That's a bit excessive. Oh well, let's turn it off, see what's going on. Okay, now remember, we've just had this thing running, which means that capacitor there is going to be charged up to 400 volts. Even though it's unplugged and turned off, it'll still have some voltage in it. It'll have a discharge resistor across it, but be careful. Let's see if we can short that out. It'll go pop. Where is it? Across there. What do we got? By the time I get to it, it will have discharged. There you go. So even that was unplugged, that capacitor is still holding power, so always be careful of that when you're mucking around with these power supplies. Alright, I think I've got it sorted. Power it up. That was my head, by the way, on the roof. Okay, there you go. You can see we've got some current regulation happening there now. I'll just have to fine tune the resistors because there's not a lot of adjustment on that little pot. Not as much as what I'd like. But that's just a matter of changing the resistor values. So it has to go over a wider range. Yeah, that's good. It's working. So what I've done, I'll just find my little semi-insulated pointer here, is I've taken positive power that normally drives this chip here, this IC, has an independent power supply. So I'm taking the power from that. I've bypassed the output of the chip through this variable resistor. One side goes back to earth and the other side goes to that little optocoupler down in there, which of course one side's at high voltage, so we can't mess around with that. Excuse me. So that's good. We've got some nice control there. Now what we can do is we can hook up our little DC amp meter here as well, and we can have a look at what sort of current we're getting. Now we've got the positive side here. This should be marked negative and positive. Hook up the positive side of the meter, and then that goes out to our load. Okay, there we go. You can see there we're doing about 2 amps. 1 amp. I hope you can see that. Interesting to see what the voltage is. Let's bring the voltage meter in here as well. I'll have a look at the voltage across the bulb. It looks quite high. Yes, 13 volts. There we go. You can see the volts there. And you can see the amps. Half an amp, 1 volt, up to 12, 13, 15 volts, 2 amps. So I'm not too sure how much electroplating system is going to need, but I have an available output there of probably 5 amps. Let's put another filament on here and increase the load a bit. Alright, so we're running both the globe filaments now. And now we're doing a bit more current there. Let's increase it. Now we're at 2 amps at 11 volts. 2.5 amps, 16 volts. We don't want to pop that bulb. Well, that's good. Alright, well, I'm going to pause. I'm going to mount it all up, make it all look nice and neat in its enclosure, and we'll be ready to do some electroplating. Okay, so we're working on our cover. Got the holes and everything done for the amp gauge. Got the power switch in there. Now we just got to put a hole for the variable resistor. All finished. Came out better than expected. Took a bit longer than expected. It looks alright, doesn't it? Should be a handy little power supply. Keep the meth lab going. Okay. Electroplating lab. We'll give it a test run. We've got the electronic load fired up. We've got the new power supply fired up, so we'll see what sort of voltage and current this is going to put out. We'll load it up a little bit, not too much, I don't want to pop anything. Alright, so as you can see the preset current is 4, and this will be the output voltage and the output current. Alright, nothing yet. One amp, 4 amps, 9.6 volts, 16 volts, 15 volts, should be good. This is the fine tune, so we'll just get this right on 4 amps. There we go, it's flickering a bit. And the meter there is, it's a smidge over, it's pretty close for what I want for electroplating. Oh, yeah, that's good. That's real good. I'm happy with that. Let's push the boundary, take it up to 5. So 5 amps was the max output of the little power supply. I may have to put some cooling holes in here. We'll see how it goes. We'll see what sort of current it needs to drive the electroplating bath. Stay tuned for that one. We're going to mix some chemicals. We'll get all these mixed up, chucked in their buckets, set up, and I'll give you a look at it. Now we've got our zinc additive. This is all got to go in the 20 litres. Well, there we go. Now basically once everything is in there, it's got to add up to 20 litres. So you don't put 20 litres of water in and then put everything in. The final quantity's got to be 20 litres. next one to go into the electrolyte bath is the zinc brightener. So 1 ml per litre of bath size, so that'll be 20 ml. Oh, that's got a bit of a smell to it. Bit offensive. Right, while that bath is dissolving, we'll mix up some of these other chemicals. So we've got the parts, the final cleaner. That is 1 part wash to 5 parts water, so we'll need... What is it? Then we got this one here is a rust and scale remover. Right, this is all completely dissolved. It feels like, there might be a little kind of couple of scrunchy bits in the bottom, but it's pretty good, I think. So now I've just got to top this up to make 20 litres, which is just to the top of that line there. It's the 20 litre mark. Okay, I'm just mounting the power supply on the wall. Like so. I might need another screw, I think. I can't get another screw in it. Yeah, 1 screw will do it. Yeah, no worries. That'll be alright. Rightio, she's all wired up. Positive onto the anodes, negative onto the cathode. And it just goes up there into a couple of banana plugs. Easy to pull those out and move things around. When you're not electroplating, you've got to take the zinc out so that it doesn't keep going off. So you just need things to be easy to come apart. Alright, next job, put some electrolyte in there. All the zinc anodes are in there now. It's just a matter of hanging them over the positive rail, like that. I guess now we'll fill it up, turn it on, see what sort of current flow we've got. We've got to do a procedure called a cooking out procedure, and what that does is remove any scum or impurities. So we just need something we don't really care about, just an old bit of metal or something, just to put in there, and zinc plate, and that'll get rid of all the scum before we start doing the important things. Alright, we're getting to the interesting end now. This is just an old head bolt. I've just buffed it up on the wire wheel. This is just a test run. See how we're going to go. Okay, into the rust remover for a few minutes. Oh, look at that, it's fizzing. Straight away, just like that. Yeah, probably should have put some gloves on. Okay, we'll leave that in there for a little while. Alright, we're out of the rust remover. Now into the final parts wash. There's a couple of stages to this. Soak it, scrub it, rinse it, scrub it again, rinse it, then do the final rinse, then into the bath. Okay, now we do the water clinging test. So we'll go into the final rinse now. And the water shouldn't bead on it, it should just stick to it. If it doesn't bead, see that, how it's not dripping off there, it's not beading. That means it's ready to go into the bath. Ooh, in it goes. Okay, that's horrendous. Okay, it's in. I'll get it turned on and then we'll come back. Right, circulation pump's running. Power's on to the power supply. You can see a little green light flashing in there, I think. Yeah, there it is. Now we're going to increase the current till we just see that part starting to fizz a little bit. This will be interesting to see how high we have to go. Oh, straight away I can see some current flow there. Oh, that's way too much. It's like 5 amps. Well, let's set it on 2 amps. Oh, we're not. There we go. Sorry about that. I might just turn that pump off so I can see if it's fizzing or not. My electrical setup here is a little bit to be desired at this stage. To work on this to make it a bit neater. I had to just put it up there obviously to keep it out of any water. Right, I can't really see if that's fizzing or not. Oh, you know, that is fizzing. Yeah. Right, that might be too much current. They said if it's violently fizzing, it's too much. So let's go back to an amp. You should just be able to see some very small bubbles coming off it. There is right on the end of the thread there. Okay, let's leave that. I reckon in about 10 minutes you should be able to see if it's starting to work or not. I've got the pump back on again, but I could see with the torch in there that there's some very fine bubbles coming off it. So I guess we'll just have to sort of play it by ear a little bit to see what's going to work out the best. But that to me already looks like it might be starting to plate up a bit, which would be awesome if it was that quick. Well, we'll get back to you when it's time to pull it out now. Just show you that. Currently we're doing about a bit under an amp. There's an interesting fluctuation to that gauge. It's vibration or the swirling of the water in the tank possibly. Interesting stuff. Okay, here we go. The moment of truth. Bum, bum, bum. Oh yeah. That's looking good for a first ever attempt. Ooh, nice. Alright, into the washing bath. Post rinse. Now it's got to dry apparently for a while. Close up view. Is that in focus? A bit hard to say. Looks good, eh? Yeah, I'm gonna have some nice looking bits and pieces. Now apparently you can buff that up and get it even shinier. Anyway, that's the end of this video. See you next time.